Hey everyone, so today we are going to talk about density. So density is how closely packed or how not closely packed uh, substances are. So if substances are really, really close together, they're going to have a really high density. So things like black holes. Things with really, really low densities are going to be spread out really far apart. So they're going to have a low density. Those are things like styrofoam and corks. All right, so density, let's define it. It is just how tightly packed a substance is. Alright, so it's just how tightly packed a substance is. And this is mainly a math subject, okay? So there's one math formula. This is our first one that we're getting into, and it's simply density equals mass divided by volume. Okay, mass is how many atoms something has. That's measured in grams. Volume is how much space something takes up, and that's usually measured in milliliters or centimeters cubed. So what you'll see from me going forward in chemistry is I'll always put my units in square brackets. So the units for density are grams per milliliter, or grams per centimeter cubed. Okay, centimeter cubed and milliliter, they're interchangeable. They're the same thing. So if you see me say centimeter cubed, it's the same thing as milliliters. One thing that's good to know is the density of water. So the density of water is a nice rounded number of 1 gram per milliliter. Okay, it's really nice, or 1 gram per centimeter cubed. The density of water is just 1. So if something has the density of 1.02 grams per milliliter, okay, it has a density greater than 1, so it is going to sink. All right? It could be 2.0 grams per milliliter, it could be 100 grams per milliliter, okay, it's always going to sink. If something has a density less than 1 gram per milliliter, then it's going to float, okay, which 0.98 is typically the density of a human. Your density varies based on when you breathe in air, you are less dense, and then when you breathe out air, you are more dense. So that's good to know with water. So since the density of water is 1 gram per milliliter, if I have 10 milliliters of water, guess how much it weighs? It weighs 10 grams. Okay? If I have 1 milliliter of water, it'll equal 1 gram. If I have 1,323 milliliters of water, it'll equal 1,323 grams. Okay, so that's a good thing to know, because sometimes I might just not give you mass of something, I might just give you the volume instead, but you know that the volume in milliliters will always equal the mass in grams. So let's go ahead and let's do a quick example just with this basic density equation. So again, our basic density equation is density equals mass over volume. Let's say I ask you a substance has a volume of 3 milliliters and a mass of 2 grams. What is the density? This here shouldn't be hard at all, right? We're just needing to plug and chug. Mass is measured in grams. Volume is measured in milliliters or centimeters cubed. So here we're looking for density. And now I need my mass and my volume. My mass is in grams, which I gave you, which was 2. And it's a good habit to keep your units in your calculations. And my volume is 3 milliliters, okay? So then when I was to solve this, plug it in my calculator, it would simplify to 0.67 grams per milliliter. Make sure you're including your units in all of your answers, okay? Units are a big help to you, and I'm going to get into that a little bit right now. You have to be able to manipulate equations, okay? So we got to be able to manipulate this to solve for volume and mass as well, because I might give you density, volume, and you have to solve for mass, or I might give you mass and density, and you need to solve for volume. So you got to know how to manipulate equations, and you got to know how to use your units to make sure that you're doing the right thing. So let's go ahead and let's just do some manipulating right now. Say I have my density equation up here, and I want to get mass by itself, right? Well, to get mass by itself, I got to get rid of that volume. Well, the way to get rid of volume is times by V, right? You got a V on top, a V on bottom, and if I do it to one side, I got to do it to the other. So mass equals density times volume. Okay, now let's look at our units and see how these match up and to make sure we're correct. The units of mass are grams. The units of density are grams per milliliter. And the density, or the units, of volume are milliliters, okay? So you got to make sure that your units are going to equal each other on both sides when it's all said and done. Well, we look at this and we see that I got a milliliter on bottom, I got a milliliter on top. Well, those guys are going to cancel out, and look at that. I got grams equals grams. That's how I know I'm on the right track. My units are matching up on both sides. Let's go ahead and manipulate this equation again, but let's do it this time for mass, okay? So I got to get mass by itself. I don't like this volume down here again, okay? I want everything to be on the same level if possible. So we'll do the same thing. So now we got volume times density equals mass. Well, again, I am trying to get volume by itself, okay? I think I said mass earlier. I mean volume. We're trying to get volume by itself. So let's go ahead and now divide by density. And now our new equation is volume equals mass over density. And again, we could use our units to make sure that's correct. All right, so volume, we measure in milliliters. Mass, we measure in grams. And density is grams per milliliter. So remember, the units got to match up on both sides in order for this to be correct, right? Well, I got grams on top and I got grams on bottom over here. So those guys are going to cancel out. But what about this milliliter and the denominator of the denominator, okay? So this is our numerator, this was our denominator, and this milliliter is in the denominator of the denominator. Well, anything in the denominator of the denominator in the basement can automatically be moved up to the numerator. All right, so now we're going to have milliliters up top instead of in the bottom. Well, there you go. Now I have milliliters equal to milliliters. All right, so you got to be able to manipulate your units. Remember, anything in the denominator of the denominator can get moved to the numerator. We see that with numbers all the time, right? If I took 1 divided by 1/2, well, you know 1 divided by 1/2 is 2. Well, look at this. These guys cancel out, right? But whatever's in the denominator of the denominator gets moved to the top. So it's 2, okay? So get used to unit manipulation, getting used to mixing those around and making sure they match on both sides. It's a huge tool in any science class, especially if you plan on going into higher level chemistries or higher level physics. Let's go ahead, let's do some examples. I got 4 for you right here, okay? Example. What is the mass of an object of volume 5 centimeters cubed and density of 1.25 grams per centimeter cubed? Feel free to pause the video and try it on your own without me going through it, but I'm going through it, all right? So I want mass, density, and they give me a volume, okay? So I know for a fact I'm going to be using this equation. If I didn't give it to you just then a little bit ago, you would know that hey, later on when we have a bunch of equations, this has density, volume, and mass, it's got to be the density equation. So right now we want to figure out mass, right? So let's manipulate this equation so that we get mass by itself. Well, we just multiply by volume both sides. Okay, now mass is by itself. Now let's plug and chug. My volume, 5 centimeters cubed. Remember, that's the same as milliliters. I multiply it by 1.25 grams per centimeter cubed. And we can always use our units to make sure that we have everything set up correctly. Okay, I got centimeters on top here, centimeters on bottom. They're going to cancel out, and I will get something around, and now I'm left with grams, which is good because we're finding mass. It'll be 6.25 grams. Okay, 6.25 grams. All right, next example. We got a block of dimension, we're going to say 8 centimeters by 2 centimeters by, run out of room, 5 centimeters. That has a mass of 90 grams. Will this block sink or float? Again, feel free to pause the video and try this on your own if you wish. So, I'm asking if this block will sink or float. What determines if something sinks or floats? It's got to be density, okay? So, again, I'll be using the density equation. I should say sink or float in water, okay? Sorry about that little addition there, but in water, right? Because in oil it might float a little bit easier, or in alcohol it might sink a little bit easier. But let's go ahead and start solving this. So we need density. If it's greater than 1, it'll sink. If it's less than 1, it'll float. So let's go ahead and find our mass. That's pretty easy. That's just 90 grams. Again, making sure you're keeping your units in there. Volume, right? We should know that if we want to find a volume of a block, it's length times width times height. In this case, it's 8 times 2 times 5. Let's do that over here. 8 centimeters times 2 centimeters times 5 centimeters should equal 80 centimeters cubed. So there's my volume. Cool, and my units match up too, grams over centimeters. So, centimeters cubed, sorry. So I will get a density of 1.125 grams per centimeter cubed. Right? And will it sink or will it float? It is going to sink. It's greater than 1. Anything greater than 1, it better sink. In water, that is. Alright, last example I'm going to walk us through, and then I'll give you one more to try on your own, and that'll be that. Alright? I'm going to throw you something else a little different here. Okay? An irregular object of 20 grams is placed in a graduated cylinder. Remember what a graduated cylinder is? Right there, right? Graduated cylinder. Went to college, so graduated. Okay? Is placed in a graduated cylinder that initially had 10 milliliters of water. After the object was dropped in the graduated cylinder, sorry, this is wordy, but after we drop that object in the graduated cylinder, it read 35 milliliters. What is the density? Okay, so you could pause that video and write that out or try to solve it on your own, but water displacement, it's something new to us, okay? That block in the last problem, that was really nice because it's just a nice cube. We know how to find the volume of a cube, but most things in life aren't cubes. They're irregular objects. So how do we find the volume of those? What we use is something called volume displacement. So, like it says in the problem, we have something like that graduated cylinder, okay? And like it said, it initially read 10 milliliters. The water always has a little meniscus. We always read the volume at the bottom of the meniscus, okay? So it initially read 10 milliliters. We went ahead and we dropped that object in there, okay? And then after we dropped it in, the new volume read 35 milliliters, okay? So this is pretty much us just calculating a change in volume. We're taking our final volume minus our initial volume, and that will tell us the volume of the object, okay? So final volume that was read was 35 milliliters. We subtract our initial volume before we drop the rock in, which was 10 milliliters, and that'll tell us that the rock took up a volume of 25 milliliters, okay? People do this all the time. They find weird metals that they don't know what they are because some metals look very similar. So what they'll do is they'll find the volume by doing water displacement, they'll weigh it on a scale, and then they'll figure out the density, and they'll look up those densities online and figure out the identity of their metal. Okay, so again, volume displacement, final minus initial, that'll give you that total volume. Density now, we could just plug in chug, which is just mass divided by volume. I'm going to go down here so I have a little bit more room. The mass was 20 grams. The volume was 25 milliliters. So our density was 0.8 grams per milliliter. Will this sink or float? This will float. Okay, less than 1, so it's going to float in water. All right. So I'm going to give you one more example that you could try on your own, and then I'll be done talking for the day. At least in your virtual world for the day, right? Okay, so here's this last problem for you to try out, and I will post the answer at the end of the video. What is the volume of a cork of density 0.67 grams per milliliter and a mass of 100 grams? Okay, feel free to try this on your own. Okay, guys, that's density for you. If you have any questions, let me know, and have a great day.